Hi, in this video we are going to see about a Python IEEE project which is entitled as Rise Varieties Identification Using Deep Learning, which is an enhancement of IEEE base paper titled Rise Varieties Identification based on Transfer Learning Architecture using Dense Ins, which is an IEEE 2025 journal paper. So before seeing the execution of the project, let me brief about this project. So we all know about rice. So rice is a very important staple food for billions of people all around the world, especially in Asia, Africa and Latin America, where rice plays a very important role in day-to-day intake of all the people. So there are varieties of rice available based on their size, shape, color, texture kinds of things. So only the manual process is available currently to identify the different types of rice varieties. But the problem with this traditional manual method is relied on the visual characteristics or prone to human error. So nowadays every field is making automation. So the agriculture field also comes with the automation, needs for the automation to ensure the food quality and the automated food processing system. So to overcome this issue, in this paper, the authors have implemented the rice variety identification using the model called Dense Ins model. So which is a transfer learning approach that integrates the DenseNet 201 and the inception model. So here the DenseNet 201 serves as a backbone for the feature extraction, and the inception model enhances the model ability to capture the multi-scale shape rated features, significantly improving the classification accuracy. So this is about the base paper, and here the authors have used the rice varieties like Arborio, Basmati, Ipsala, Jasmine and Karakadak. So these are the rice varieties they have used, and kindly note that we are not going to do the same as mentioned in the base paper. So now let us see what is the future enhancement that is mentioned in the base paper. So here they have mentioned some future enhancement. In that you can see that this model is not a lightweight one, so they have suggested for a lightweight deployment so that it can be increase the accessibility on site speed, quality assessment and automated classification in the agriculture industries. So now let us see about our proposed system. So we have implemented this rice variety identification using two different models. The first model using DenseNet 121. The second model is MobileNet. The first model, DenseNet 121, we have achieved the accuracy train score of 99.0% and accuracy test score of 99.3%. Next, for the MobileNet model, we have achieved the accuracy train score of 99.4% and accuracy test score of 99.5%. So now let us see about our proposed system. As mentioned, the proposed title is Rice Varieties Identification Using Deep Learning. Here you can see the abstract of the IEEE base paper. Now coming to our proposed project abstract. Here you can see the introduction about the rice and the need for it, and you can see about the proposed title and the challenges that is available in the traditional method. So we have developed this project using Python for the backend logic, and for the user-friendly web interface we have used HTML, CSS and JavaScript and deployed using the Flask web framework. So here we have used two convolutional neural network model, DenseNet 121 and MobileNet. So here the DenseNet 121 model achieved the training accuracy of 99.0% and test accuracy of 99.3%, while the lightweight MobileNet model outperformed with the training accuracy of 99.4% and test accuracy of 99.5%. So the data set, coming to the data set part, so we have used total 60,000 rice grain images. So here the 60,000 rice grain images, and the classification is the same classification that is mentioned in the base paper, that is Arborio, Basmati, Ipsala, Jasmine and Karadagat. So each classification, so here each classification contains 12,000 images for the training purpose. Now I'll show you the data set part. So in the model part we have this data set. So here in the training part we have the 5 classification. In the first, let me go to the Arborio. So here in the Arborio you can see there are 12,000. Can you see 12,000 images of this Arborio rice variety. Next one you can see the Basmati. Here you can see that is 12,000 items, and you can see all these 12,000 items here. Now coming to the next classification, Ipsala class. So here you can see for this rice variety also contains 12,000 dataset images. Next, coming to the Jasmine rice variety, you can see the Jasmine rice variety images, which also contains the 12,000 images. And finally the Karada. So here you can see this Karada rice variety images. So you can see all the 5 has some different shapes and texture kinds of details. So this also contains 12,000. So the total training images contains 60,000 rice grain images. And finally the results demonstrate that the proposed deep learning based system can reliably distinguish between the related rice variety with high precision. So coming to the existing system, so we are going to consider the base paper as the existing one. So in the base paper or the existing system, they have made the classification of rice grains based on the dense INSUB, so which contains a combination of DenseNet 101 and Inception. So here in the workflow of the existing system begins with the acquisition of the rice grain images, followed by pre-processing steps such as grayscale conversion, binary thresholding, image correction, edge reduction kinds of thing. Then the data set also used in the base paper contains 5 varieties like Arborio, Basmati, Ipsala, Jasmine and Karadagat. So the data set is then processed and fed into the DenseNet architecture for training and classification. So DenseNet 201 is known for the dense connectivity and effective feature reuse service as the robust backbone in the model, while the Inception model enhances the feature extraction by analyzing the spatial features at multiple scales. So here they have achieved 99.94 accuracy. The system is designed to contribute the real world application in rice grain quality inspection and classification, supporting the sustainable agriculture and food traceability. So now coming to the disadvantages of existing. So the main disadvantage of the existing system is high computational complexity, because the combination of the DenseNet 201 and the Inception model results in the deep and complex model architecture. So this demands a significant computational resources both in terms of memory and the processing power, making it less suitable for deployment at low end or low edge devices such as mobile phones or embedded system. Next one is the large model size due to the number of layers or higher. So here the model size also increases. It may comes around 90 MB size. And next disadvantage is longer training and inference time. Next issue is limited focus on lightweight deployment, absence of real-time application demonstration, and finally no visual interpretability features. These are the main disadvantages of the existing system. Now coming to our proposed system, as mentioned, we are going to develop an efficient and accurate rice variety classification model by leveraging the deep learning technique using DenseNet 121 and MobileNet architecture. So here we are going to use the same classes of the images Arborio, Basmati, Ipsala, Jasmine and Karadagal. Now here in the backend of the system is developed using Python and front-end contain HTML, CSS and the JavaScript. So the rise grain images are processed through series of data processing steps, which includes the defining the data directory, setting the image dimension, rescaling pixel values and loading the structured data set. So these are the data processing step, deprocessing step, and then the data set is these steps are made to ensure the input data for the training model. Then it is sent to the training model. So there are two distinct models. One is the DenseNet 1-to-1, another one is the MobileNet. So both the models are trained separately and their performance are evaluated using training and the testing data set. And the standard metrics such as accuracy, confusion matrix are used for assessing the system. So here the advantages of a proposed system. The first advantage is lightweight and efficient model. Next one is high accuracy with reduced complexity, faster training and inference times, deployment ready for web and mobile platform, reduce resource requirements, scalability and flexibility, improved real world applicability, supports real-time prediction. So these are the main advantages of our proposed system. Coming to the system architecture, here you can see the data acquisition part. We are going to give the input as the rise images data set. Here the pre-processing is done, which are the steps like defining the data directory, setting the image dimensions, image rescaling, data loading and structuring. Then it is given to the training part, which uses the model DenseNet 1-to-1 and the MobileNet, and the predicted results will be predicted in the 5 classes. Then we show the performance analysis with the accuracy, precision, recall and F measure scores, and we show the confusion matrix of each model, and then finally we show the static visualization graphs. Now next come the system requirements. These are the minimum hardware requirements and the software requirements. This project can be executed in Windows 10 or 11. The coding language we have used is Python 3.12.0. Web framework is Flask. Front-end part and HTML, CSS and JavaScript. This is the IEEE base paper reference. Now let us see the execution of the project. So before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of Python or libraries installed in the system. Now go to the source code location. Inside that we have this rise varieties identification. Now in the address bar, let me type cmd, so the command prompt window opens the exact location of it. Now type python space app.py and click enter and kindly wait for a few minutes. So now copy this URL, go to any of your browser. I'm going to Google Chrome and paste it, click enter. So now you can see the project home screen or welcome screen with the project title Rise Varieties Identification using Deep Learning. Now you can see this login menu. Just click this login menu. Kindly note that this is a static login menu because we have not used any database in the project. So just enter the default username and password as admin and click login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part where you need to upload the rise grain images and you can see the predicted result. So now let me select the choose file option. Now go into the project source code location. Inside that we have this test data folder. You can go to any of the class and select. I'll show you each class now one by one. So now let me select an image. So now you can see the preview of the image and you can select the model here. So here in the model part, you can see, as we have mentioned, we have used two different models. You can select which model you wanted and based on that model the predicted result will be shown. I'll show you the first case with the DenseNet 1-to-1 and click the submit button. So now after some time you can see the predicted result of it. So kindly wait for a few seconds for the first time. So now you can see it is navigated to the predicted result page. So now you can see what is the image that we have selected and you can see what is the model that I have selected as DenseNet 1-to-1. The predicted result you can see it has scripted correctly as Arborio. And now if you wanted to check with the other one, so just go to the preview part again. So now let me select the same image and I'll let you go for the MobileNet part and click submit. So now you can see the predicted result for the MobileNet also predicted as correctly as Arborio. So now let me go to the preview part again. I'll just go for the next class and I'll select an image and I'll just go the submit button. And now you can see the model selected and the predicted result is Basmati. So now let me go to the preview menu again. I'll just select the other image from the other class, and let me click submit. So now you can see the printed result is Ipsala. And let me go to the preview part again, go to the choose file and go to the Jasmine class. I'll select an image and click submit. So now you can see the printed result is Jasmine. And let me go to the preview part. So now let me select from the other class and click submit. So now you can see the printed result is Karakdak. So now I have selected each image from each class and all the result was fine, correct. And if you wanted to check with the training data also, let me show you that. Just go to the model part, the rise image there. I'll just go to the train part. So there are lots and lots of images. You can select anything whichever you wanted randomly and click submit. So now you can see it has printed correctly as Jasmine. So in this way you can check with the other images that is provided in the test and train cases. So now here your question is whether it can predict the other images. No, it will not predict other images. For example, if you are giving some fruit image or some other object image, it will not predict, because the model is trained only with the rice grain image of these 5 classes. So once if you're going to give some other image of the rice grain, so you need to make sure that the size, the type of the image, and this model, whatever the model that we have given, in the same format it should be, and then you can do it. So if you wanted to give some other class or you wanted to give some other image, you need to train the model again, the backend part, then only it will be giving the exact predicted result. So other cases it will not give any other, you cannot give any other images, because the model is trained with only with these 5 classes. So now let me move to the next step of the performance analysis part. So just click this performance analysis. So in the performance analysis, we'll be seeing the accuracy, precision, recall, F score, F measure values of the 2 models. So first one is MobileNet model performance analysis, where the accuracy value is 0.996, precision value is 1, recall is 0.996, F measure value is 0.996. And next comes the confusion matrix of the MobileNet model. Here you can see the confusion matrix with the true and predicted label of it. So now the performance analysis of the next model, that is DenseNet 1-to-1. So here you can see the accuracy of the DenseNet 1-to-1 is 0.993, precision is 0.999, recall of 0.993, F measure value of 0.993. And then comes the confusion matrix of the DenseNet 1-to-1 with the true and predicted label of it. So here you can see a complete performance analysis of our model. And finally comes the chart part. So this is a static visualization chart. So here we have the first chart as the model accuracy chart, which shows the accuracy of train accuracy and test accuracy of both the MobileNet and DenseNet model. So in the MobileNet you can see the train accuracy of 99.4%, test accuracy of 99.5%, and in DenseNet 1-to-1 train accuracy of 99% and test accuracy of 99.3%. So this is the model accuracy graph. Next comes the dataset class distribution chart. So as we have mentioned, all the classes has the same number of images, so it has been split into 20%. So Arborio 20%, Basmati 20%, Ipsala 20%, Jasmine 20%, and Karadaga as 20%. Next graph is the DenseNet 1-to-1 training versus validation accuracy plot. So these plots are being platted in the backend model, and it is been shown in the front end part. So these are the static graphs. And next comes the DenseNet 1-to-1 model loss graph with the loss and epoch of it. Next comes the MobileNet training and validation accuracy plot, and final graph is MobileNet model loss graph. So in the graph part we have these graphs, that is first one with the model accuracy chart, and second one is dataset class distribution chart, third one is DenseNet 1-to-1 training versus validation accuracy plot, fourth one is DenseNet 1-to-1 model loss graph, fifth one is MobileNet training versus validation accuracy plot, and final sixth one is MobileNet model loss graph. So these are the 6 graphs that is available in the graph part. So now let me log out. So before concluding, let us see the frequently asked questions for this project. So the first question is, what is the purpose of this project. So the answer of for this question is the project aims to develop a deep learning based system that can automatically identify the different rice varieties. So the classes of the rice varieties are arborio, basmati, ipsala, jasmine and karakdak, so based on the images of the rice grain. So the purpose of this project is to help in accurate classification of various applications in agriculture and quality control and food processing. So this is the main purpose of this project. Second question, which deep learning models are used in this project? So we have used two convolutional neural network models, DenseNet 1-to-1 and the MobileNet. Third question, what is the accuracy of the models used? So DenseNet 1-to-1 achieved 99.0 with the train percentage and 99.3 for the test, and for the MobileNet 99.4% of the training accuracy and 99.5 for the test accuracy. Fourth question, what data set are used for this training model? So the rice grain images dataset contains 60,000 images. 12,000 images per class is being used for the 5 varieties. Next question, how can a user interact with the system? So user can upload the rice grain images to web interface that is developed using HTML, CSS, JavaScript, powered with the Flask backend. So based on that uploaded images, the model predicted results and it shows in the result page. Next question, is internet required in this system? So the internet is not required because it is going to run in the localhost only, but we need internet for installing the required libraries or packages for the project. Next question, is the system suitable for industrial or commercial use? While the system demonstrates the high accuracy and efficiency, it is currently designed as an academic project only. For industrial deployment, we wanted to make some additional stuff for robust testing on real world dataset expansion and API integration so that it can be used for the industrial or commercial use. How does this project differ from the IEEE base paper concept or the existing one? So unlike the base paper concept, they have used dense insub, which is a complex and heavy weighted. So that is the main drawback of the base paper. So from that we have developed a lighter model with two different distinct model, DenseNet 1-to-1 MobileNet, so that it achieved the same or equivalent results with less computational cost. That is the main difference. What are the main features of our system? So the main features are like we can upload and classify rice images via web interface, real-time rice variety prediction, high accuracy using deep learning, support two model choices. The user can able to select it, and responsive and user-friendly user interface. So these are all the main frequently asked questions. So this is all about the project rice varieties identification using deep learning, and thank you for watching.